Hi, my name is Elizabeth Hubler. I'm a junior in mechanical engineering at GW, and I just won the 2013 Undergraduate Prize at the R&D Showcase. So my research is looking at the airflow through human vocal folds and how it's affected if you have polyps or other voice deformities. And this is really important because in a person's lifetime, 30% of people will be affected by some kind of voice disorder, and this number increases to 60% for people who use their voice on a daily basis, such as professors or singers. So what we're doing is looking at, we have an experimental setup which is basically a synthetic vocal tract all the way from your lungs to your mouth. And the first part of our project was to look at different ratios of silicone to try and replicate like the physiological vocal folds. So we mixed different ratios of silicone and made different vocal fold models, which we put into our experimental setup. Our experimental setup allows us to take the pressure readings at different points along the vocal tract. And we're working now in collaboration with the speech and hearing department at GW to use a tool called a Rothenberg mask, which measures the air output when a person speaks. So we can take our tests from the clinical test, or our results from the clinical test, and compare them to our results from our experimental setup, and hopefully improve our vocal fold models, which will help with basic science right now for other researchers who are trying to look at the voice and look at how vocal folds move. And then further down the line, our research and our basic setup will help developing different like medical procedures or different even like prosthetics for vocal folds like farther down the line. So it's important that we use our research to try and create better vocal fold models that more closely replicate the human vocal folds.